Okay, come, let's go. First page, okay, for the benefit of people who have not touched this topic in their entire lives, I'll go through every single MCQ. Okay? After all, today we're ending at 7, so.
What?
What?
You said 6:30.
No, I said 6:45.
No, 6:30.
Okay, come. In your ESP, okay, your fan blows dusty air, blah 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 blah. Okay, large potential difference. Okay, this guy is connected to your positive terminal, plus plus plus. These fellas, okay, these metal rods will give the particles a negative charge. Okay, if you guys paid attention during my static electricity lesson, you will know this is how your ESP works. You have a negatively charged, very very strong negative field. Okay, so when particles pass through, they gain electrons, and then they get attracted to your metal plate, and hence everything after the metal plate is clean. Or the dirty shit gets collected on the plate. Are we okay? Get that? Yes. The rods? No, the rods are very, very negative. Yes. Okay, because these guys are the ones that are positive now. So these negative ones, when you in between them, they have a very strong negative negative field.
So it makes the air negative.
Correct. It makes the particles that are passing through gain electrons. Okay. Yes. Via friction. Friction. Can use elimination, yeah, of course. Like how you cannot gain protons and you cannot lose protons. Okay, if you lose electrons, you become positive and you move away from the metal plate, but you are trying to stick to the metal plate, right? So this one is wrong. Okay. Okay, in exam you can use any method. There isn't a hard and fast rule. Okay, question 2. Negatively charged negatively charged rod. Okay, stream of water. So obviously, all your positives are going to want to come to one side. Alternatively, you can see it as all the negatives will be repelled because they are like charges. Same charge, push each other away. Simple? Okay, yeah? Good. Okay, I will ask you guys whether you have any issues. Okay, if you do not, then I'll just move on. Alright, a wire has a current of 500 milliamperes. Okay, please convert this. This is 0.5 amperes. Okay, so formula, current equals to flow of charge per unit time. So if I equals to Q over T, I is 0.5 amperes, Q is unknown, T is 3 minutes, so you have 3 times 60 seconds. And then you calculate Q, half times 3 times 60 gives you 90 coulombs. Any questions? No, huh? Let's carry on. Question 4. Okay, if you have the same volume, okay, can you guys tell me what the volume of a cylinder is? Anyone? What's the volume of a cylinder? This is math. Pi r square h, okay? Fair enough, it is indeed pi r square h. Alternatively, you can also see it as area times height, right? Or area times length in the case of a wire. So, if you have 4 times the length, okay, your volume is A times L. If this fella times 4 means your area times what? Quarter, right? 1 over 4. Alright? Okay, because they are inversely related. So, if you want to calculate resistance, that's rho L over A. Okay, your length times 4, area times 1/4. Okay, if you isolate the multiple, 4 over 1 over 4 gives you 60. Are we clear? Okay, my priority will be those who are actually getting tested for this. Okay, everybody else, try to follow if you can, alright, but like I said, don't feel too bad about how you did. Alright? A student tries to charge a metal cylinder by following the sequence. Okay, you have a positively charged rod over here. If you have a big source of positivity, all the electrons are going to want to come to this side. Everybody wants to get attracted to the left. Agreed? Okay, which means if this student touches it, his electrons as well are going to want to come in. Fair enough? However, what this student did wrong is he removes the rod first. If you remove the rod, Okay, let's say this fella disappears. Okay, let's black him out a bit. Okay, once he's gone, all the electrons flow back. All the electrons flow back. This guy goes back to zero charge. You cannot possibly tell me that you can remove your finger faster than the electrons come in. Not possible. The moment your positively charged rod is gone, all the imbalance is neutralized. Everything becomes in charge again. Are we clear? Okay, let's carry on. Okay, question 6, your filament lamp. Very. Your filament lamp, what happens to resistance when current increases? Resistance will also increase. Okay, the link between these two is temperature. The more you have, the higher your current will be. Okay, the greater the charges are flowing. With more flowing, you have more friction, temperature goes up. When temperature goes up, resistance goes up. Okay, but R is equivalent to V over I. So if this fella is increasing, that simply means that your voltage is increasing faster than your current. Because no matter what, they are both going to be increasing. It's just about who increases more. So select the graph where your voltage is increasing faster than your current. Okay. Spend some time to look at this if you need to. Okay. And then, okay, you can exaggerate it a bit. Okay, you can see the graph will slowly go like this. What are the other three graphs? Okay, this one, okay, when your I increase and T increase, resistance goes down, right? This is your thermistor, which I went through in current of electricity as well. Okay, for those of you who are not tested, please, okay, I don't want to stress you guys out, okay, for your WA1s, alright? Study the topics that you need to study. However, I don't give a shit about WA1, correct? Okay, my focus, my priority is the big guy at the end. So, after your WA1 is over, please do your own revision, read through my notes. Okay, if your school notes start, read through my notes. Okay, this one for B is a semiconductor diode. Very negative, reverse bias, no current can flow. Correct? If you're going the wrong direction. Okay, and for A is just a homing conductor. A simple homing conductor, metal wire, resistor, all this kind of thing. Okay, question 7. Okay, a stationary negative charge in an electric field experiences the electric force and blah, 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 blah. Okay, again, if you are negative and you are going this way, means this side is what? What charge on the right side? Positive, right? Negative will be attracted to positive. And if this right side is positive, your electric field always goes away from positive. So your electric field is that side. Okay? If they ask for electric field, it depends. If let's say this was a positively charged object, right? And he's going this way, that means this side is negative, then your electric field is going towards it.
So you always get like main conductors like that.
Yeah, your electric field is always from plus to minus. So if this minus is coming this way, means whatever's on the right side is positive. Means your electric field should be going in the opposite direction. Okay, so Xavier asked me this as well just now. What does into the page mean? Okay, into the page refers to your charge, your electric field going like this. In other words, we are focusing on a 3D diagram now. We will discuss into and out of the page when we get to electromagnetic induction. Okay, or electromagnetism. Okay, then we start dealing with this. Your father, mother, child, or whatever. Huh? Not necessarily, because if I'm focusing on, okay, So let's say I have this scenario. Okay, so your focus, your idea is going to chemistry a bit already, yeah? Because you have a lot of protons here, and then you can have electron here, electron here, electron here, electron here. Right? Possible, correct. But when I have an electron going this way, I cannot be so bold and like, oh okay, my perspective somehow shifts to this side. My perspective has to be based on this that they show me. Which means that if your electron negative going this way means a positive will go in opposite direction. I mean the diagram is given to you for a reason, so you have to listen to it. Okay, question 8. Question 8, use formula on the board over there. V equals to E over Q. So energy equals to voltage times charge 15 times 120. Nobody should get this question wrong, especially those of you who have done this topic before. Okay, apply formula, get answer. Very simple. When a boy took off his layer of coat, he observed sparks. Okay, I'm not sure how many of you have experienced this before. Okay, but I experience it like fucking every night because my blanket is made of wool. So it's like fucking annoying. Okay, so basically, okay, you will cause friction, okay, due to contact. Okay, you touch, okay, there will be a lot of friction, you generate charges. Okay, this is your electrostatic discharge. If you are confused, read through the notes. Okay, second last page, there is a question on it. Okay, the boy touched the doorknob and whatever shit. Alright? Humidity lower, all this kind of thing. Maybe true, I don't know, I cannot remember my job anymore, but fuck it lah, okay, cannot possibly be the answer. Alright? More charges in the air during winter makes no sense. Temperature difference. What about temperature difference? Okay, forget about it. Question 10. Resistance equals to voltage over current. Alright? Right. Hey, from P to Q, what's my potential difference? It is gradually increasing, agree or not? But what's my current? Pretty much 0. Agree? Okay, I can put any number x on top. If I divide by 0, the answer is always infinity. True? You divide by an infinitely small number. And use common sense. If you have infinity, which is the biggest number possible, can you increase beyond that? Alright, from infinity, it has to be a downward trend. That's it. Clear? Any questions? Javier? No? Question 11. Okay, two metal spheres mounted on insulating stands. P is positively charged. Okay, so we can calculate this. Okay, let's say I got +4 here. I have a +4 charge on P right now. Okay, you are going to provide a pathway. Okay, because Q is uncharged, right? So you're going to provide a pathway for electrons from Q to jump ship over here. Right? And the thing is, you are maintaining contact, which means possibly all 4 electrons are going to go. And then this guy attains a 0 charge, this guy attains a +4. Agree or not? Okay, this is what we would expect to happen. But if I maintain contact, then down here is +4, down here is 0, what do you think the electron is going to do? Come back. Right? So it doesn't make sense to go down there and then come back, go down there and come back, then the +4 keeps swapping sides, man. Very, pretty much impossible. Because in fact, what is actually going to happen is, the only way your charges stop flowing is if both sides experience a +2 charge. You have equal attraction on both sides, your electrons don't know where to go. They will just stay where they are. Your metal rod is just the path. It is the pathway. That's fine. So in that case, then all your charges will just be split. Your positive will just be split among all 3 objects now. But because from the very beginning there is an imbalance of negative and positive, overall must still be positive. Okay? So if I am touching somebody else, we will share. If that person touches somebody else, the 3 people will share, and so on and so forth.
So, why doesn't the metal rod why doesn't the electron in the metal rod?
it's very possible that this guy gains, let's say he gains the +4 or he gets a +2, for example. So +2 here, +2 here. Can. But then he's touching him, why would he not share? This guy also wants in on the action, right? Your positive, regardless of the magnitude, will split equally among all three. Okay?
Uncharged means neutral.
Uncharged means neutral, yes. Warm, right?
No.
Owen, question 12, you okay? No. Okay, 10 ohms, 5 volts. What's your current? Two? Okay, there is. V equals to IR, mate. I can know. So what's the? Agreed. Okay, 0.5 amperes. Okay, then we apply formula again. 0.5 amperes. Okay, Q equals to I times T. 0.5 times 50 minutes. 0.5 minutes. 0.5 minutes times 60 seconds. Okay, go ahead and calculate. You will get 15 coulomb. Let's carry on. Question 13. Okay, 1 joule of work is done to move 1 coulomb of charge between 2 plates. Okay, from this information, which one must be true? Okay, your potential difference. Okay, remember, joule of work. Okay, this energy per coulomb of charge is voltage, which is potential difference. So if I have 1 joule over 1 coulomb, then it will be 1 volt. Not much else to mention apart from this. How do I know it's 1 joule? Because they tell me it's 1 joule, right? Good. Okay, Question 14. Anybody got it wrong? Okay, in between your two repulsive forces, this is neutral. No force, no nothing. Okay? So I can put a supercharged object there. Nothing's going to happen to it. Question 15. Okay, neutral conducting rod touches a rubber balloon. This fella is a conductor, this fella is insulator. Can you guys tell me? Petra, if you insulator, your electrons can jump ship. Can move from object to object, you think? You can. If I rub because of friction. Right? Your friction will enable the charges to jump. But am I rubbing? I'm not. Okay, I'm touching. Okay, the fact that you touch, your charges cannot move over. Cannot move over. Nothing. You cannot achieve anything. There is no flow of charges. The rod stays neutral. The balloon stays positive. If it was a conductor versus conductor, different scenario.
So nothing happens.
Not literally nothing happens. Okay, Alright. This part's going to be a bunch of copying. Okay. So let me explain first. Otherwise, later when you're copying, you're not going to pay attention to what I say. Alright? Okay. This fella is now very, very positive. Okay, there is a lot of positivity here. So, if I bring him close to sphere B, the electrons in sphere B are going to go where? Left side or right side? This way, right? Your electrons are all going to want to come here, man. All the electrons are going to come to the left side. Okay, which means if I have electrons that are coming from Earth, they themselves want to go this way. True? The fact that I can pass by, your electrons can pass by your emitter means there is current. There is a flow of charges which will generate a deflection in your emitter. Okay, so read through. Okay, electrons in the earth attracted to your positively charged A, since unlike charges attract. Okay, so you'll move from the earth through the wire to your steering. Okay, then since current is rate of flow of charge, you will have a deflection. Okay, you're done. Part B is very simple, so I have to rush through it. Good. You got correct. Not bad. Okay, do your corrections, guys. Already, is it clearer now? Is it clear? Yes. Wow. Problems? No one? From the other side, from him. Because I'm not doing anything to him. The emitter isn't even connected to him. Alright? So I move closer. Okay, then your electrons will all want to go this way, right? Which means the electrons that are coming in from Earth will also want to go towards him. The part for what? Oh, the electrons going. Because they are already inside the ball, so they don't flow past your emitter. Right? You can add it in, but it doesn't contribute any current because they are already inside. Yes? Okay, the right side is an induced positive, then. Yeah. Then. Okay, you can say that electrons, okay, electrons attracted to your induced positive RHS of B. Yes. This can also take the place of your first mark. Oh, this one you wrote? Yeah, that's okay. I thought you meant these electrons, like inside the ball one. Yes, of course. 3 marks. Questions? Questions? Owen? Good? Good, huh? Okay, the second question is very simple. Q equals to I times T, 2.3 times 10 power negative 7 coulombs. It's a free 2 marks. Okay, apply formula. Okay, please tell me you all know your prefixes by now. Okay, small m is 10 power negative 3. Yeah? Yes. I gave it out to like my set 2 who's now going set 3. Set 2 notes? Go see. Why do you need set 2 notes? Set 2 notes is legit nothing. Like, what is speed? Distance over time. Okay, next. Electrostatics can be a nuisance. Okay, this person walked across a carpet. Okay, we are focusing on electrostatic discharge for this question. Okay, so he becomes charged by friction as he moves across the carpet due to a transfer of charges. Okay, now let me caution you guys against something. Okay, I saw quite a few of your answers for this one. Do not say electrons transfer from the person to the carpet or carpet to person. We do not know that. We do not know who is transferring to who is gaining, who is losing. So just say transfer of charges. If you want to say transfer of charges between man and carpet, fine. Just don't say transfer from who to who. Because we do not know much. How do we know that we are the ones gaining or we are the ones losing? It depends on the person. Okay? It also depends on the material of the carpet, all this kind of shit. So we do not know. Then when you touch, okay, you have a sudden discharge. This is your spark. The Z that you feel. Okay, the spark. Okay, that when you just before you touch, or in fact it's pretty much when you are close enough such that the electrons can move over. Are we okay? Okay, go ahead, write your answers if you want to. I'll move on to. Okay, next. Javier, what are you doing? Okay, spray painting, small drops of paint, positive charge, blah, 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 blah. Okay, what happens when there's no charge? Obviously, everybody just flies in fucking random directions. Okay, so the drops spread out more quickly. When you pass through your paint nozzle, the question tells you already all of the drops acquire the same charge. If you are positive and you're positive and you're positive, 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 everybody is going to repel each other away. In fact, your guy doesn't look like this, it will look like an arc. He will literally like this, he will spread out like that. Okay, that's why if I have a negative here, then everybody starts to curl in. To get attracted. Following? Okay, so how are we going to explain that in words? Okay, we are going to say positively charged droplets experience an electrostatic force of repulsion since like charges will repel each other away. That's all. 1 mark, 1 mark. Okay, in fact, let me just say, okay, we do not really agree with how the school marked that thing here. This should just be 1. It should be a 1 mark question. Okay, you spread out more when you leave the nozzle because everybody's positive, same charges push each other away. Questions? If not, okay, why do you reach the back? Because obviously there is going to be attraction. Okay, attraction from your positively charged particles to your negative leg chair. Chair leg, what the hell? Okay, so reaches the back because you are attracted, okay, since unlike charges attract. This should be 1 mark, same as this one. Is that okay? Good. Javier? Problem? If not, okay, I will slowly scroll. Okay, this answer is pretty simple because the two of them are very similar. Good. Let's move on. Okay, so now you have a circuit, simple circuit containing blah 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 blah, cell, switch, whatever shit. Okay, define the term current, rate of flow of electric charge. Okay, alternatively, you can say amount of charges flowing through a point per unit time. Also can. Okay. Amount. What is amount of charges flowing per unit time? I will give you, but careful, because I'm also give a shit about you. Correct? Okay, 11.2 shows how current flow varies with dimensions of blah blah blah. This question, okay, this following question is going to be a bit calculation intensive. Okay, so bear with me for this one. Alright. Describe how current varies first. Okay, we are going to say directly proportional. You can say it increases when cross-sectional area increases. The need for directly proportional is not required. Okay, one go up, the other go up. Done. 1 mark. Okay? Okay. Now, you guys, okay, you all can flip the page if you want to. Take note of what the question is. I will stay on this part. So, your resistance formula is R equals to rho times length over area. Which means if your length doubles, your resistance should also double, correct? If your length times half, your resistance will also times half. True? Okay, so Another formula we will need is V equals to I times R. Okay, I will explain later. So, firstly, okay, if your length, the length they give you in the question is 150 cm. Agree or not? Okay, if I half the length, this guy times 0.5, means your resistance also times 0.5. Linear proportion, true? Am I going too fast? No, huh? Okay, then what about your cross-sectional area? How's your area changing? From 12 become 24. Right? Okay, if your area times 2, what happens to resistance? If I double my area, what happens to resistance? Times 2, okay, yes, down here will also times 0.5, which means your net change on resistance is how much? Times half give you? Yeah. Okay, your R becomes times 0.25, a quarter of its original value. Right? Okay, then from this point it becomes a math question. Okay, your voltage is the same, right? You're using the same freaking battery, correct or not? Okay, so if this guy is the same, this fella times 0.25, what happens to your current? You will times 4. Down here, decrease by 4 times, that one must increase by 4 times, huh? Agree or not? To maintain the same potential difference. So from 0.45, your answer should be 1.8 amperes. Anybody got this? Good. Good.
I didn't.
Oh, you didn't? Hey, you like? Okay. Questions? Okay, so in working wise, this is how it will look. Okay, but I figured if I explain it to you guys that way, it will be a lot easier to understand. Any questions? Sure. You get it? Good. Okay, uncharged metal sphere, insulated thread between two metal plates X and Y. This guy connected to positive, negative, so this fucker is obviously positive and negative lah. Right? Okay, your positive terminal will lead to a positive plate. What you are going to do is you are going to force your metal sphere to touch X, which is a positively charged plate. His electrons are going to flow away. Agree? In fact, his electrons are going to go all the way down towards your positive terminal, aka he becomes a positively charged ball. Okay? Okay, then they say, okay, this part B is quite difficult to answer. See how many marks you guys can get. Okay, so after you release this fella, now he's positive, right? Will he stay with X? X is also positive, okay, they will push each other away. In fact, in addition to the pushing, he will also be attracted to hit. Because he's negative. Which means that obviously he's going to go up. Okay, your positively charged sphere, don't start writing yet, pay attention first. Your positively charged sphere is attracted to Y because your unlike charges will attract. You can include the repel from X if you want to. Alright, you can write either one or you can write both. Up to you. You still count as 1 mark. Okay, your second mark. When you touch Y, negative charges from Y will flow in. Remember, you are a positively charged ball now, right? You touch a negative plate, okay, Y will gladly give you electrons. And he will give you until you flip to the other direction. You become negative. And then you will go back to X and become positive. Go back to Y, become negative. Good. Okay, so if you are okay with this, alright, then you can start writing. Make sure, if this question does come up again, you know it. Okay, this question came up in last year's mock paper for the Sec 4s. Alright? You all should be okay with this.
When you say like,
Yeah.
it is made to touch X, right? Wouldn't that mean that the sphere is negatively attracted to like the positive X?
But you didn't get attracted to X. It's I push you until you touch X. So you didn't get attracted. I forced you to touch it. then the electrons inside your ball will happily go out because it's a positive plate. Then you become positive, and then you all start pushing each other away, and then the ball will try to reach the negatively charged wire. Okay, then once it touches, okay, Y will overcompensate. I give you too many electrons, you become negative. And then you get attracted the other way, and then you repeat. Alright, okay. Yes. Based on your terminal. Your positive terminal is where your, okay, remember your electrons, your electron flow is always this way, right? From negative terminal to positive terminal. So if your negative terminal is like this, means down here got fucking a lot of electrons, bro. Correct? So it's negative. Okay, conventional flow is current, which goes from positive to negative. Okay, but exactly what is flowing is not physics. Okay, it's actually these things called holes. When electrons go, then they leave holes behind. Don't worry about it. Okay, just think of current as flow of charges, coulombs. Question? Yeah. Correct. He will move away, touch, exchange charges, move away, touch, exchange charges, move away, touch, move away, touch, move away, touch. And this will literally happen forever until your battery runs out of power. Good. Go ahead and write down whatever you feel like you need to write down. In a practical, it's very unlikely that you will be required to do something with enough charge, such as it oscillates back and forth, because it is dangerous. Imagine let's say this is the object, right? And then the plate here, I push. The electrons from the ball are going to go in, right? And we, being conductors, will also lose electrons. Do you know how okay, it depends on how powerful the battery is, obviously. But if I want this oscillation to happen, I will need like at least hundreds of volts, 150 maybe, or more. You should try it, honestly. How about you stick a fork inside the socket, right? You let me know how it goes.
No, my friend did that. We put things inside like the socket during physics lesson. To test out some physics.
Yeah, anything happen?
Oh no, fortunately or unfortunately.
Oh man, it's not powerful enough, bro. You have to wet the fork.
Yeah, we use like metal and like graphite.
Okay, next time after you shower, right? You just hold a piece of metal, then you throw it, you just push it into the plug connector. You let me give me a call after, let me know how it goes. Okay? Okay, next. Let's go for question 20. Okay, producing sandpaper using static electricity. If you spray glue, as the glue leaves the spray gun, the glue droplets break up into tiny, negatively charged particles. Okay, all of your droplets become negative. What is an advantage of having all of them become negative? It's the same advantage as your spraying shade. Correct? Okay, everybody will push each other away. Negatively charged particles repel each other, causing them to spread out and form an even layer. Okay, you can say something like spread out evenly would be accepted. You can say something like reduce wastage also can. Okay. Cook evenly, spread out evenly. Fine. Very good. Next, okay, remember you're supposed to bring your sand to coat your paper. This fella is your paper. This is your paper. Okay, he is going to attract your sand upwards because your blue droplets are all negative. Okay, so you have negative blue droplets and you have a positively charged plate that's in contact with your sand. Obviously, your sand, when it passes through your positively charged plate, the electric field causes them to obtain a net positive charge. Okay, this question is the hardest question in the paper, okay, because very few schools will teach this. Okay, that the electric field can actually cause an insulating material to obtain a charge. This is the concept that we use in your electrostatic precipitator. Okay, do you guys ever wonder, hey, my ash particles that are flying through conductors, man? If not, how they gain electrons? It's because the field is so strong that I throw the electrons to you. Then your positive charges will be attracted to your negatively charged glue. Okay, you do not have to say adhere, you can say stick, or you can say remain on the glue. Fine. We have 2 more questions. Hang in there. Okay, especially those of you that have been here since 2 o'clock. Okay, figure 6.1 shows the experimental setup to obtain the fixed value of a resistor. What's the resistance of your fixed resistor? Voila. What's the resistance? What do you calculate? R equals you didn't do? Why? No time. Okay. I tell you okay, use this formula. V equals to I times R. How to calculate resistance? Agree. 3.0 divided by 0.3. Okay, you will get 10 ohms. That's your answer. Yes. Okay, next, resistor is a 2 meter long constant current wire with a diameter of 0.2, blah blah blah. Okay, you are replacing it with a shorter wire with a thinner diameter. Now, with that being said, okay, currently you have 10 ohms, okay, V is 3 volts still, okay, I is 0.3 amperes, and resistance is 10 ohms. All of this, with the exception of your potential difference, is about to change. Okay, your I and your R will both change. How? Because, again, we are going to utilize the same formula. Okay, so the ones in red would have been my working for part B. Okay, you can look through it. You can look through this one later and see if you understand. Okay, but I don't like to use the proportion symbol. So let's just explain it normally. Rho L over A, your length times 0.5. What's the effect on resistance? Xavier. Your length going from 2 meter to 1 meter, what happens to resistance? Half as well. Owen, my diameter is half from 0.2 to 0.1. What happens to resistance? Area. Thank you. Decrease by how much? Is it also half? It's not half. Then it's how much? Times 4? Okay. Friendly reminder, area equals to pi r squared, or you can see it as pi times d over 2, whole thing squared. Radius is half diameter, right? Or you can see it as pi over 4 d squared. Point is, the relationship is not linear for these two. How would figure it out? If this guy times half, what's the area? Relax. We have a lot of time. Correct? The only person allowed to leave early is Jack and Karina. Because they are the only ones who weren't here last week. Right? Yeah, you can stay. I think if you have to, you are allowed to leave early. But the rest of you, I owe you guys half an hour. Oh, and you? How?
I leave early also, right?
Sorry?
I leave early also.
Can you give me the answer first? And no, you cannot leave early. Because you leave early also, you still cannot walk very fast, so there's no point. Hey, don't stress, relax. Okay, what? You look here. This fella, square is this guy, right? Okay, so if your diameter times 2, your area times 4. Agreed? If your diameter times 3, your area times 9, right? So now this guy times half, this one times? Agree. But if your area times 0.25, Zelda, if area times 0.25, what happens to resistance? Shut the fuck up, I heard it. How? No? Anyone? Times 4. Right. Which means your resistance value times 0.5 times 4, your net is just your new resistance, A, is double. True? So what's your new resistance value? It becomes, okay, our new resistance is 20 ohms. What does your current become? What does your current become? What does your current become? If your resistance, your new resistance is 20 ohms. What? Your brain fried already. Okay, guys, if your freaking resistance times 2, then your current is times half lah. Your final answer is 0.15. Okay, 0.15 amperes. This is the actual working. I don't really agree with it because they use this symbol. I don't like it. Okay, if you want to, you can copy this down. Although I'm quite sure my work is better. What's up to you? Because your length times half. So it's not times half.
As in the current.
Oh, current. Because V is constant.
Yeah.
So if your resistance doubles, then your current is times half to compensate. Okay, last question. 6:15 now. We have half an hour for one more question.
So don't need.
So don't need.
So you use that one.
Oh, is it? I'll take my little sweet time. No, just kidding. Okay, so you have a IV characteristic graph for a simple diode. Okay, resistance is very large when PD is negative 2. Javier, what are you doing? Very. How does resistance change as PD increases from negative 2 to 2? From this point to this point. Resistance is decreasing, okay. See guys, if I switch this question up and I ask you, let's say it's a fucking VT graph, okay? Let's say like a graph looks like this, for example. Alright? And this is time 3 seconds, this is time 1 second, this is time 2 seconds. I ask you to calculate, I ask you to describe to me the motion of the car or the motion of the object from 0 to 3. Will you just say that, oh, it's decreasing then increasing? You split it up, right? 0 to 1, 1 to 2, 2 to 3, correct or not? Okay, those kind of questions, at least 3 marks in exam. This is no different. Okay, there is a very clear distinction from your straight line until it changes here. Right? Okay, so it will be in our best interest to split it up. Besides, it's 2-mark question. Don't skip. Okay, from negative 2 to about 1.25, we are set 1.3 or 1.4. Okay, your resistance is at infinity or at a very, very large value. You can say very large value. Because again, this is any random voltage divided by 0 amperes. Anything divided by 0 gives you infinity. Okay, then from 1.25 to 2, resistance decreases from infinity to about 200 ohms. How do we get 200 ohms? Gradient power minus 1. Cool. How to find the gradient? No, it's actually just getting, it's not even gradient in the first place. It can be calculated like gradient, or you can just find out your V here, is find out your I here, and then find out your V. You just count, no, at this point, because I'm calculating until 2.0. At 2 point, it's not gradient. At 2.0, it is V over I. Your V is 2.0. Your current is 10 milliamperes. So if 2 divided by 10 milliamperes, we get 200 ohms. Right? That's how we get it. Okay, 2 differences. Let's wrap this up. Okay, your metal wire is an ohmic conductor. You have a linear graph for all values of V, while the other fella clearly is non-linear. That's difference number 1. Difference number 2, you can talk about negative bias or reverse bias. In the negative direction, okay, no current can flow. No current flow for diode. Okay, the other guy still can allow current to flow. Are we okay? This one. So your I draw below. Okay, so your graph for semiconductor diode actually follows like this. Right? Your ohmic conductor is like that. So in other words, the first difference is after, right? Varying versus constant. Second difference is in the backward direction, this side still can flow, this side cannot. Yeah. Your third difference, if you want to, is about threshold voltage. Here. Questions? Good. Okay, if not, then I will stop the lesson here for today. Oh no, looks like I still owe you guys 10 minutes. Don't want to waste your money lah. I feel a bit.
Let's do consult.
Consult for 10 minutes. Group consult.
Yes, yes.
Wow. Shoot.
Can you do
Peace.
PEC?
Is that practical electricity? No. Literally only you know it.
I also never been a in school.
Then wait for me to go through in class.
You take so slow.
Your school is ridiculously fast. Come, y'all can ask any question for WA1 prep. It's up to you. You want waves, you want light, sound, kinematics, measurements, whatever shit, also can. Up to you.
Can you give us practical for electricity?
There will be a practical for electricity. We already have the materials in July.
Only in class.
We will most probably do it in class. Yes. Obviously not. What? No. Yes. Question 5. What about question 5?
Can't you just see it as like because the person is holding the positive charge block, right? Doesn't it just become
That's actually a very good question. It doesn't really follow the concept that we're trying to teach, but yeah, sure. That's interesting. The what? Two balls with metal rods. Yes. No, it's from Q to P first. It's from Q to P because P is positive. So he will be the one taking the electrons. It stops only when they're equal.
Can you give a more like visual like context for this question?
Visual context. Okay. Let's say you have ball, and ball.
Right.
Oh, sorry. Let's separate the balls. Okay. Right now this guy he's the one with the positive charge. So let's say maybe I have 2 electrons and maybe 2, 3, 4, 5 positive. Okay? Okay, the rest is all minus plus. Okay? So once all these guys come into contact, touch and touch, this minus is going to come over here. Okay, I realize I don't have enough minuses. Let's add a couple more. Okay, so once they all touch, his electrons going to come in here, over here. His electrons also going to try and go over here, right? That means this guy is gone, this one is gone, he'll be over here. This guy is gone, he'll be over here, for example. Right now he's neutral. Not sure if you realize. Okay? Sorry, right now he's +1.
Is it all the negative
This guy is +1.
charges go over?
If all negative go over, he becomes negatively charged and these two are positive, right? Then he will give back, right? You will keep giving, there will be flow until we decide, hey, we are same charge. I will give you, you will give to me. As long as there's an imbalance, there will be a flow. Correct. So if you're positive and I'm neutral, I will keep giving you until, if I give you, then you become neutral, I become positive. You'll give back.
And the reason why only 2 minuses are there is because you want to neutralize it.
No, you want everybody. The flow of charges only stop if everybody has the same charge.
Okay.
Yeah. Yes.
In the question, how you know it's equilibrium?
In the question, how you what?
How do you know it's equilibrium?
Because the only way that charges stop flowing is when there is equilibrium. It's like,
How do you know when?
I don't know when exactly it will happen. I just know that if from the very beginning, this guy is positive, his positivity will spread to anybody who's touching him. Yeah.
Okay, so it's positive. Okay, so if you go back down to the
Correct, Katie, if y'all have no questions, then you guys can
to the
Oh, to the
okay, so it becomes positive, then that's neutral.
No, he's also positive. He has 5 positives and 4 negatives, so he's still +1.
You want to stop your recording?
Oh yes, oh my god.